tell me a bit?
Yeah, so there must be a button on your screen only saying you can stop sharing your screen now.
Okay. Did it unshare now?
Yes, sir.
Okay, all right.
So good evening, everyone. Uh, Principal Prem Prakash sir, Vice Principal Ma'am Manoj Kumar sir, and my fellow students and my colleagues. I welcome you all to this mesmerizing evening in which we have a guest, and I just ask my Vice Principal Ma'am Miss Manisha, you can to welcome our guest.
Okay, good evening everyone, and good evening Shri Sunil Kumar Agrawal ji. On behalf of the management, teachers and students, I extend my heartiest welcome to you, sir. This is the first in series of the various webinars which would be organized to expose students to the varied career opportunities which are now present in the environment, and we are really pleased that you are the first person, or you are the uh, uh, first contact resource person who would be speaking to these students, because the field of your work is absolutely amazing and really interesting. Once I was going through your biography, I was interested in personally wanting to ask various questions to you. Tell you more, the students to tell you more about Sir. He has received a PhD degree in mechanical engineering from Stanford University in 1990, and he is currently a professor and director of robotics and rehabilitation, that is ROR laboratories at Columbia Universities, which is located both in the engineering and medical campuses of the university. To tell you about the work, the amazing and interesting work which sir is doing. So you all know about neural disorders and old age limit the ability of humans to perform activities of daily living. So robotics can be used to probe the human neuromuscular system and create new pathways to characterize, relearn, or restore functional movements. So Dr. Agrawal's group at Columbia University, that is the ROR laboratory, has designed innovative technologies and robots for this purpose. So these technologies have been tested on subjects in a variety of studies to understand the human cognitive and neuromuscular response. And human experiments have targeted patients with stroke, cerebral palsy, Parkinson's disease, ALS, vestibular disorders, and elderly subjects, among the other things. This talk will surely provide an overview of some of these technologies and scientific studies performed with them. And so, especially the students who are thinking of taking up medicals may have a new insight into their career option. So, sir, heartiest welcome to you, and we look forward to a very interesting and interactive session. Thank you so much, sir. Welcome to the session. Along with this, I also welcome our principal, who is the key or the sole person who actually is able to bring about all of us under this umbrella of Career Counselling Mela, along with the career counseling team, the teachers, and the students. All of you are welcome to the session. And over to you, Dr. Sunil.
Thank you, Manisha ji. I hope you can hear me. Can you hear me well?
Yes, sir.
Okay. Thank you, Dr. Prem Prakash and Advita ji for hosting this session. What I would do is try to share my screen. Let me know if it is working first of all. Okay. Are you able to see the screen and hear me?
Yes, sir. Yes, sir. We can see your
Okay.
screen.
Okay, wonderful. So it's a real pleasure to be with you all. Just to kind of give you a small background, I grew up in Patna. And in fact, I went to school along with Prem Prakash. We were batchmates in St. Xavier's. So, of course, Patna has a lot of fond memories for me personally and for my family. So after finishing my high school and then 2 years inter-science at Patna Science College, I went to the Indian Institute of Technology in Kanpur, where I did my undergraduate degree. And subsequent to that, I was interested in basic science, and I came to Stanford University here in the United States, and that's where I conducted my studies. So by training, I'm an engineer, and after I finished my PhD, I became a faculty member, and I've been teaching in the university for the last close to 30 years or so. And all of you know about robotics. Yeah, robotics, we see lots of pictures and things in our daily life, which sort of has been influenced by robotics. And mostly the pictures of robots are something that you see in an industry, yeah, where cars are being assembled or maybe they are painted by robots. And that's where robotics first started. So if I were to sort of go back 50 or 60 years ago when the robotics field started, that's how it sort of started out. And people saw a lot of applications of robotics in manufacturing, in industries. So even today, when you go to some of the major companies, you will see assembly lines with robots and others. Now, so my laboratory or my research kind of took a course where we wanted to explore how robotics can be used for people in their daily life, right? And especially with many patients who may have suffered a disability, or they may lose a function, or they may have sort of an incidence of a stroke or a spinal cord injury, or maybe just people getting older and they're not able to sort of do their daily life activities. And the question we were asking is, how can I use robots in a completely different setting where the goal is to be able to look at robotics and how it can sort of help people in their daily life. So currently, I'm a professor at Columbia University in New York City. I'll tell you a little bit about my university and the work that I am doing. Now, at the university, I have a position both as an engineer or as an engineering faculty, as well as a medical faculty. So I sort of share the interests or the needs of both from an engineering perspective as well as a medical perspective. And I hope that I can share some of that with you. Can you see a new slide? Okay.
Yes, sir. Yes, sir.
Okay, wonderful, wonderful. So this is about the university. So we are in New York City, and I'm sure that you are seeing a lot of news right now about the elections happening here in the United States. So our university is located in Manhattan, and Manhattan is sort of the center of New York City. So so tall buildings and things like that, that's what defines New York City. Just to kind of give you a historical perspective of the university itself, we are one of the oldest universities in the country, and we have something called a U.S. News and World Reports. I mean, just like you have a local ranking of different universities in India, similarly, the United States has this world rankings. And Columbia University is considered to be the number 3 university in the United States, after Harvard and So it's a very competitive university. In fact, this is the first university that offered a degree in medicine. So Columbia actually offered the first MD degree historically. That was about 200 years ago or so. So it's a very prestigious university. I mean, some of our alumni have been people like Barack Obama, they have been up to 85 Colombians who have received a Nobel Prize by the Nobel Foundation. So, bringing a little bit about why we need to think about robotics, right? And so these are some slides that are taken from the World Health Organization, right? And there are several key things that I want to bring out here. First of all, we know that our society is getting older. Okay, and what that really means is that there are more people who are 65 years or older. Okay. So what that really means is that a lot of people are getting older, they have a longer life. And the question is, how do you support these people who have this kind of long lifespan? Also, if you think about it, I mean, there are a lot of people around in our society who have got disabilities of various kinds, right? People who are on wheelchairs, who need prosthetic legs, who need, let's say, canes. And the question is, of course, I mean, there are technologies like that, but what can we do, or how can we sort of take these technologies in the 21st century to bring in advanced ideas into it? So here's just a visual here. Again, it's a very busy slide. I apologize for it. But these are a lot of different visuals from our laboratory. And so we work with very small babies, infants, to all the way to very older people. And what is interesting here is that the technologies that you can design can be sort of scaled to younger or older people. And a lot of these ideas can be applied to yes, any comments, any questions?
Oh, ऐसा इज्जत पे.
Okay. All right. So I think there's a disturbance.
Yes, Piyush, I ask you to
भाई
mute
हम भी
your
तो बहुत
mic.
कम खाए हुए इस बार यार.
Piyush, hello, can you hear me? Please mute your mic.
Okay, so I'll continue.
Yeah, we are good to go. Yes, muted.
Okay, so here a couple of things that I want to highlight here is that a lot of people in our society are getting older, and with old, a number of impairments come in. So, for example, people, if you look at the slide, the picture out here, these are just older people walking, and some of them may have an incident of a stroke, right? Or somebody may have a injury in the spinal cord, or maybe if you look over here, this is a picture of somebody with a Parkinson's disease, and so in our activities of daily living, I mean, there are questions about how do you balance yourself, how do you walk, how are you able, right? So the question here is, how can you use technology? There's some disturbance on the way.
I request all the students to mute themselves.
Okay. All right. So the idea here is, if you think about the human body, right? The human body has the brain, right? That sort of is the big. I mean, this is the organ that is sort of developing the control commands to the human body, and of course, some of those the commands sort of go through your spinal cord, right, which is at the back of your body, and through the spinal cord, there are lots of nerve signals, right, which can be communicated to the muscles, and the muscles then eventually go in and kind of make the movement. So many of you are sort of familiar with, so this is sort of an equivalent of a robot, in this case, the brain, which kind of acts as the computer, And then the wires are kind of run through the spinal cord. And eventually you have the motors, which are like your muscles, which can sort of create these functions. And what has been shown in the human body is that the brain has the ability to learn if you were to provide a lot of repeated experience to it. And often people with, let's say, stroke or other kinds of injury, you may be able to teach the brain to be able to send those signals to the human body, so that way you can kind of perform those functions. So part of the fundamental idea that we have that we work on in our lab is to be able to retrain kind of the cells in the brain to be able to perform those activities, which may have been sort of lost because of the incidence of a stroke or maybe a partial injury to the human body and things like that. So, so the overall idea here is that the brain has the capacity to learn. So those of you who are high school students, right? Or many of you are high school students, and you are thinking about what you want to do in the future, right? And of course, there are so many different skill sets or opportunities that you have as you grow up, right? And one of the important things is about human body. And of course, some of you would become doctors, some of you become engineers, but there's a possibility for you to sort of combine those ideas together, what you learn in engineering and what you learn in medicine, to be able to sort of help humans sort of perform their activities better. So what I'm going to do here is walk you through a few simple sort of videos and examples of what we do and how we do it. And then later on, we sort of give ample amount of time for you to ask questions. And that way, you may be able to sort of clarify more of things that you heard. So, so here is an example of one of our projects. And what you see here is somebody who's walking. And he's an older gentleman. And he has had an incidence of a stroke. So I want to tell you a little bit about what a stroke is, right? So, of course, your heart is pumping blood to the different organs in your body, and this blood is sort of pumped through various vessels and capillaries in the human body, right? And sometimes what happens is that the capillaries or the blood flow gets blocked, right, because of maybe something that is sort of occluding the flow of the blood. So what happens is that a particular organ is not able to get the blood, and as a result of it, they're not able to function. And similarly, if you think about the brain has got these microcapillaries that is getting the blood from, and some of those get blocked, and as a result of it, the cells in your brain sort of temporarily are not able to function, or they die. And as a result of it, people are not able to do various functions. So it's called ischemia, or in fact, many of you who are reading about COVID, there have been lots of cases where people after the COVID have had some clots, and as a result of it, they have a stroke. But also, I mean, stroke can happen in other ways as well. So once your brain cells are not able to work, and let's say those cells were supposed to sort of control your movement or your function. So another question is, some other cells in your brain have to take over that function. So what we have here are some patients with stroke. And after a stroke, you would typically recover, but you would have lost some function. And in this case, the individual has lost his walking function. He's not able to sort of do that very well. And what we have done is designed a machine here that you see attached to the human leg. So for example, the picture that you see here. So this particular machine is really something that connects to your leg. And it is able to supplement, let's say, torque on your joints. So if whatever you could not do by yourself because of your lack of coordination or muscle weakness, now you're able to supplement that with the robot. And what we do here is we look at the inputs that are made by the machine and the human in a way that you balance, you cooperatively sort of work them together in a way that you are able to sort of regain your lost function. And while you're doing this, you're also kind of training your brain or the cells or some other cells in the brain to sort of take over. So here's a video of this. So I'm going to let this video play one more time. So this typical training happens in a 3-month period. And the patient will come to our laboratory many times, about, let's say, 15 training sessions. And in each of these sessions, we'll challenge the person to walk in a faster way. And the machine is then supplementing. And the goal is that the patient sort of relearns how to walk. And as you can see here, in the video on the top, the person is, that was the first session before the training. And the video at the bottom is the session, say, after the training. And this training, and you can see here, he can walk a lot more faster, more stably. And of course, in a medical study, you just don't kind of work with only a single person, but you work with a group of individuals and look at what kind of functional benefits you get as a result of this training. And in this case, what you see here is a graph that says that if I had 10 patients in our study, overall, the subjects sort of improved, say, between their speed of walking before the training, immediately after training. And what was even more interesting is that we brought these patients 6 months later on in our laboratory, and we could show that these patients are able to walk even better than what they did while they were in the training. So that sort of gives us evidence that there is a possibility for us to retrain the walking of these individuals through this kind of a robotic training. And of course, I mean, there's a lot of research kind of going on in this across the world, and people are sort of seeing how you can take this technology further. So from other technology point of view, one of the challenges that we had was once we created this machine, I mean, those machines are fairly bulky and heavy. Just to kind of give you an idea, those machines were almost like, say, 30% of the weight of the human body. So that was still okay to do that in the lab, but if you want these machines to be used in the home environment, then you want that flexibility of lightweight and be able to sort of carry along with you. And so some of our subsequent efforts have been to sort of reduce the weight of this machine from 20 kilograms to 2 kilograms. And we have these kind of various novel ways of redesigning it. And in this case, the way this is designed is like a puppet. And in this puppet, a lot of these wires are controlled. And you can see all those wires here in this video. But those wires are basically run through those red tubes. And through the tubes, I mean, we are able to sort of pull these wires just like a puppeteer would do. And we have sort of used this technology to test it again on stroke patients. And this is a study that we recently conducted. And as you can see here, through this machine, we can actually have these patients actually walk in a way that can assist these movements. So you can see here in this particular video, with the assistance of the machine, the patient is able to walk faster, and you can sort of tune the machine to sort of give you the kind of changes that you are expecting after the training. So let me kind of move to another different device. And in this case, it's sort of motivated from this picture of this mother who is holding the child. And when a child is learning to walk, you would normally apply some sort of help to the child's pelvis. And what we try to do is we could replicate the same idea into a machine. And as you see on the video on the right-hand side, this person is kind of walking. Okay, instead of the hand of the mother on the child's pelvis, this hand is replicated by a bunch of these wires, and you can sort of control the tension in the wires to give support to the individuals, just like how they are walking. So I want to show you a video of another group of patients that we work with, and these are children who have got cerebral palsy. And in this video, you can see that this young teenager who is walking, but his knees are actually flexed, and these are called crouch gait. In other words, the person is not straight or erect, but he's actually crouching on the ground. And of course, I mean, these kinds of gait patterns have a lot of difficulty in terms of the quality of walk, as well as it's not very helpful to the joints, because often people have something called osteoarthritis, and kind of these are diseases on the joint because of excessive or unusual loading on the knee joints. And we actually conducted another study where we tried to see how we can make a better gait for these individuals. And I just wanted to kind of show you this video here. These children were actually brought into our laboratory, and we trained them over multiple weeks with certain downward force. And the motivation here is that when you walk, you kind of move your pelvis up and down, and in the phase that you're kind of lifting your pelvis up, you are basically making your muscles of the knee a little bit stronger. So you can see the video one more time here. This is the video of the child walking before the training and after the training. And then you can see that the child is walking a lot more erectly, and his knees are not as bent as in the other video. If you want to sort of look at how these children were trained in the machine, this is when they were actually being trained on the treadmill with this device. And there were lots of, and you can look at a lot of physiological patterns in terms of how your muscles are firing, what your kinematics is, what your forces that you're applying on the ground, and so forth. And they were all very positive in terms of this training. This is another study that we do where it's called a trunk support trainer. So again, many children with cerebral palsy, they have actually very poor control on their trunk. And so this is a child with cerebral palsy who's sitting, but is not able to sort of put his trunk straight. So, and we know that the trunk is very important for us to kind of do our daily activities. For example, today when you are listening to me, you are kind of sitting with your trunk straight, right? Or you are able to write with your pen, or eat and other things like that. But on the other hand, if you cannot control your trunk, then you cannot sort of conduct your daily activities. So I'll show you another technology, again, in a very briefly. This is, I'll let this video play and I'll talk about this. So as I said, children with poor trunk control, and in this case, you see a child who's sitting on this bench, but she doesn't have a good control of her trunk. And in fact, the trunk, your head, arms, because all of these things need to be coordinated in order to sort of do an activity. And this child doesn't have a good control of it. And so one of our physical therapists is working with this child. And the goal of the therapy is to be able to have the child kind of go much further away from the neutral position, which is the sitting position. And we train the child over many sessions. And this is a video of the same child after the training. And what you can see in this video here, the child is able to sort of go much further from her neutral position. And she's able to sort of recover coming back to the neutral by herself. And in the beginning, we used this belt with these wires that you saw. And those wires are effectively giving her the confidence and the support that she would need in order to sort of get back to the neutral position. But over time, you change to kind of use these muscles and coordinate them in a way that can help you to complete the function. So this is a study that we have actually just recently published. So this is a second child. And again, you can see he also has a very poor control before he came into our study. And the same therapist is working with this individual to see if he can challenge the child with the cerebral palsy to go much further away from the neutral position and try to sort of come back to him. Now you can see that belt that he's wearing, and that belt is essentially kind of acting as a support system and which you can modulate over time. So, and this is a video of the same child after the training, and you can see how nicely. He's able to sort of come back to his base after the training with our machine. So again, this is a very interdisciplinary group of people. Some of them are my students in engineering. Some of them are physical therapists. And of course, I mean, all the patients are recruited through our pediatric neurologist. A very interdisciplinary work where you can sort of combine people from different disciplines in order to sort of get to your goal. This is another group of patients, and these are patients who have got a spinal cord injury. And as I talked earlier on, spinal cord is the pathway between your brain and your muscles, right? And now if you have an injury of some sort and that cord sort of gets severed at different positions, then in that case, I mean, you are not able to communicate between the brain and your muscles. And many of these patients with spinal cord injury, they again have the same difficulty of not being able to control their trunk very well. And one of our research projects is see how we can use our machines to help these individuals reacquire some of the lost sitting function. This is another group of patients, and these are called patients who have got a head drop. And I don't know how many of you have heard about this disease called ALS. This is called amyotrophic lateral sclerosis. I mean, many of you may know of Stephen Hawking, who used to be a professor in England, who had an ALS and is considered to be one of the geniuses in our times. And if you remember his pictures or videos, he would be in a wheelchair, and his head would really be kind of flopped. I mean, he would not be able to control his head or any kind of muscle, because in this particular disease, your muscles progressively die, and the only thing that you are left with is just your movement of your eyeballs or your pupils. And so we want to sort of see how to create machines that can allow individuals with poor head control. And of course, it's important for patients with ALS or anybody who has got a head drop. And in fact, we know that many older people have, as you progress in age, some of the controllability of your head neck sort of decreases. Even in our current society, when you're using computers a lot, I mean, you have a bad sort of posture of your head neck. So we want to sort of see how to use a robotic device to be able to assist or maybe retrain kind of movement of your head neck. And what you see here is a person, he's wearing a head neck brace, and there is a shoulder mount, and then there's head mount. And in between, you have these mechanical chains, and those are essentially controlled by motors. And these are things that we have actually built and patented in our laboratory. And in this case, we are looking at how to use these for patients with ALS. So I'm going to show you a video again. Okay, and here you see actually two videos. On the left side, you see a patient with ALS who has got a poor head control, or actually a head drop. And what we're trying to do is have him actually follow an avatar on a screen. And if you see on the screen, there is an avatar who's kind of moving his head. And that is sort of given as a cue to the patient to see if they can control their head in the same pattern. And of course, without the support of our brace, so if you look at the left video, the patient is not able to control his head, and that's why we need to support the person through the hands. But on the right-hand side, you can see that that once you are able to control the neck brace along with the individual, then he is able to sort of make those movements. So this is an example of an assistive device, because these patients with ALS, since this is a neurodegenerative disease and it sort of progresses, there's no way to kind of reverse that degeneration. So in this case, the machine is really acting as an assistive device for these individuals. So let me kind of this is our last slide, just to kind of tell you that Again, the robotics, even though we are talking in the context of humans, but we also do a lot of robotics in the context of animals. So, for example, you can see this video of a rat, and he has got a robot connected to his arms. And part of the motivation here is to understand how and a rat with a certain injury, let's say injury of a spinal cord or a stroke or some other aspect of the disease, and how they sort of recover. How does their kind of neural system sort of recover over time? And those can give us a lot of good insights into how to apply these to humans as well. On the right, this is our group. Again, we have a very multidisciplinary group. We have a lot of engineers, a lot of medical doctors. We have lots of MD students. And as also you can see here that we have a really kind of mix of girls and boys. In fact, our laboratory actually has more girls than boys, at least currently on it. So that means whether you are a boy or a girl, it sort of doesn't matter. You can be equally successful in completing the goals that you have chosen for yourself. So I'm going to stop here and let you ask questions because I know that some of this is a little bit sort of beyond what you have learned in your curriculum, and I'm sure that you may have many questions to ask me as we go. So I'm going to stop sharing the screen and come back to the main.
So, thank you, sir. I think that was very perceptive, and everybody's fascination has always started with robotics, but it is much more than that. I've learned today. It is directly connected to our life, and as in a society, it is said that everything is interconnected. That is why we live in a society, and engineering and medicals is so much connected. And we learned it throughout this session. So I'd like the students to raise their hands or maybe ask their questions by writing them in the chat box. So I'll take up the question. I'll just tell it to our guest, and he can answer all your questions.
Yeah. Thank you, Advita. And yeah, I'm happy to sort of take any questions from you all. And I know that when I was your age as a high school student, I'm sure that I would have had a lot of questions when somebody like this was presenting to me.
So, sir, our first question is, if the college doesn't offer a stable robotic engineering, what would be the best course for the same? Electrical engineering, mechanical engineering? What would be the best? Yes, sir.
Okay, so this is a very nice question, right? So, I mean, the way our society right now is laid out, right? I mean, you choose professions, and these are sort of compartments in some sense, right? Whether you choose an engineering degree or a medicine degree or maybe a financial degree and so forth. But if you think about the real world, right? Real world is not compartmentalized. When you create a machine or you create a solution for somebody in the society, that solution really requires you to kind of think it very interdisciplinary. I mean, the financial part is as important as your engineering part or medical part. So to answer your question, if you were choosing a degree, of course, I mean, a degree gives you a first step towards where you want to be, but you have to sort of constantly challenge yourself, like learn new things, and that way you can see with your current knowledge how you can advance it to a point where you can sort of make an impact in the society. So to answer your question, whether you want to do electrical engineering or mechanical engineering, in my view, I think all of these are very good disciplines. I myself was a mechanical engineer, but that doesn't mean that I only can do mechanics. I mean, we kind of have knowledge of computer science, electrical engineering, medicine, and it's up to you to find your own path to see how you can impact lives of people.
So yes, sir. The next question is, automation is future. Is robotics or computer science a better choice?
So again, it's a great question. So if you think about robotics, it's really kind of an integration of a lot of different ideas, right? A typical robot would, of course, use mechanical design, right? But also use electronics. Okay, it needs computers, so everything that is programmed. So we write our own computational codes and things like that, right? So it's a really an integration of so many different disciplines: mechanical engineering, electrical engineering, computer science, right? Psychology or medicine, and so. So automation, of course, is a bigger word. I mean, robotics would be considered a sub area of automation. But again, I mean, as I said, I mean, these compartments that we sort of create are sort of very artificial. What we are all limited by our own understanding, and I think we have to sort of expand that. Of course, I mean, the robotics can be used in industry. There's a lot of need for that in the society, but also in your human life.
Thank you, sir. So the next question is the upcoming nanotech being used for medical sciences purposes part of robotics? And how do we pursue that? Do we need a medical degree for that?
Okay, so again, it's a very, very good question. So everything that we talked about here today were at a sort of the size of these machines were in the order of, say, kind of half a meter or in sort of 50 centimeters or 100 centimeters, right? So like a meter. But a nanoscale is you're going at a sort of a scale of a millimeter or maybe even 1/10 of that. And in fact, there is a lot of study out there in the field of robotics, which is sort of focusing on to that scale. And some of these, and some of these robots are also sort of used in the human body. So yes, I mean, if you look into the literature, there is a lot of study in terms of how you create these millimeter size devices or micromillimeter size devices, and there are lots of applications of that, including the human body.
Yes, sir. Thank you for that. And the next question is, what is the state of such incredible work and rehabilitation in India? And what about the cost involved?
So again, it's a good question. I mean, so this this field of rehabilitation robotics is not a very old one. I would say it's about 25 years old, and it is sort of a growing area. And this is something that is sort of pursued around the world. And in fact, I have a lot of colleagues in India who are doing various aspects of rehabilitation. And so I have friends at the various IITs, Kanpur, Madras, Delhi. So yes, I mean, it's a growing trend. And in fact, if you think about it, there's more need for technology for everyone around the world. It's not that sort of something kind of limited to Western countries or United States. I mean, there's a bigger need for these kinds of technology in India. And I think it's going to continue to grow.
Yes, sir. So our next question is from Rahul. Sir, as you said that you have done mechanical engineering from IIT Kanpur, and I am also interested in computer science engineering. So, sir, do the robotic science also need computer science engineering?
Yeah. So again, it's a good question. I mean, as young sort of enthusiastic persons like you, so of course. IITs, of course, are good places where you can kind of really learn many different things. Now, computer science and engineering, I mean, they are all kind of they're intertwined with each other, right? So when you do mechanical engineering, I mean, you are actually you may be actually exposed to computer science and vice versa. So as I said, in this real world, I mean, all the different disciplines sort of touch upon each other. So if you were to go into engineering school, I mean, you would do classes in computer science as well as in engineering. And I think both of them are important. And they would sort of help you to come up with solutions of real world problems, because the real world problems require you to integrate ideas across disciplines. And so you would need engineering and computer science and medicine and many others to in fact be successful in whatever you want to achieve in the future.
Yes, sir. So Satyam asked, sir, who was your inspiration?
That's a great question. I think our inspiration are our teachers, right? So, for example, when you are at Radiant, I mean, you have got this fantastic group of teachers and administrators. When we were students, I mean, we had some role models at that time. And of course, I think a lot of this motivation comes out from people who sort of teach you, because they are the ones who sort of bring in that fire in you that you can do something and you can accomplish it well. So really, I think in my mind, my inspiration for all my teachers.
So the next question is from Ayush. So what are your thoughts on solar engineering, and what would be the best course for the same?
Yeah, well, as the society advances and as the needs of clean energy, and we want sort of have many of these technologies develop that keeps the earth and the environment safe. So I think there is a really, in my mind, I think solar energy is a very important technology. Now, I don't think that there are any degree programs in solar engineering. That means you'll have to sort of really do a classical sort of engineering degree, and then you can sort of take classes and focus on kind of studying specifically in the area of solar engineering.
So next question is from Sarthak. Sir, the mechanics that we just saw were way more complex than any normal one. How would we mass implement it?
Yes. So, of course, I mean, these the technologies that you saw in my videos, they are definitely complex. But once you have created the first machine or first design, then it can be improved upon over time, right? So at this time in our research, we don't sort of worry as much about the issue of manufacturability. Our goal is to sort of look at the fundamental science and be able to show what is possible to do. And once you have actually shown that a certain idea works, then you can sort of translate this idea into a manufacturing device. So that's what engineers do, is kind of take an idea and see how you can optimize it to be mass manufactured and sold to the society and things like that. So cost and other things, that's something can always be fine-tuned in a way that is sort of appealing to the society.
So the next question is, sir, I'm interested in designing. So which field should I go, mechanical or automobile? And he's asking for your suggestions.
Yeah. So again, I mean, so design is a very broad subject, right? So design, I mean, you can have an electronics design, you can have a computer's design, right? Or you can have the software design. So design is a very sort of a broad field. And so design is really a philosophy, right? And you can apply that philosophy in any kind of specialized area. So I would say that it doesn't matter what particular discipline that you go into, design is something that you will sort of develop as a part of the discipline. So whether you are doing an automotive design or you're doing software design, I mean, design is really kind of a method or a philosophy, and you would do this to improve upon on your goal, basically.
So the next question is from Satyam again. Sir, I want to become a game designer. Is there any specific course for that?
So again, so yes, I mean, computer science would be a good lead into it. But I'm sure that a good designer doesn't necessarily have to be limited by any coursework, right? You can be a good designer, or you could be sort of a good game designer just by experience. I mean, you can play with it and see what are all the necessary skills that you need to learn, and those skill sets will sort of get you to advance to these goals. So, for example, if you think about people who build Facebook, right, or use Microsoft, I mean, they did not have a degree, right? They started out with in a college, and they decided that that's not what they wanted to do, but they had a passion and they want to sort of work on their passion. So, of course, I mean, a degree doesn't necessarily, I mean, degree is a facilitator, but it's not required. And as long as you are really passionate about something, you can achieve it just by sort of tinkering along with it and be able to sort of get to your goal.
So thanks. Next question is from Sanskriti. So what do you think are the secrets behind getting to where you have to go?
Again, I think it's a very deep question. And I think the secret to your success is your passion, right? You have to you have to sort of put in the time and effort and whatever it needs to take to get there, right? And that will happen as long as you have, first of all, there has to be a will, right? And also you have to be able to put the efforts that is necessary to sort of get you there. So in my mind, I think that's the foremost thing that you need to do in order to be successful in what you want to achieve.
So, yeah, sir, that is, so there's one more question. So I want to become a software engineer. Is it necessary to take computer science?
So again, it's a great question. I mean, of course, if you were to take a class in computer science, you would be introduced to the formal training that is required for you to be a software engineer. But as I said, I mean, you have the knack for it. You have the skill set. You may be able to sort of even without getting that degree, or you can. So in my mind, I think the degree is a facilitator, but it's not required. As long as you have a passion for it, as long as you have a knack for it, you can sort of learn many of these things on your own. But of course, I mean, a degree would sort of help you get to that goal quicker and earlier because you would have a formal training to be able to achieve that. So I would sort of recommend that you have a degree in computer science because that'll give you the formal methodology of how to accomplish your goal, which is to kind of develop these great software.
The next question is, sir, in automobile engineering, a single person designs the car, or there are different people for engine design, model design, etc.?
So we have to sort of keep this in mind, is that when you think about a product, right, that's like an automobile or maybe a television or sort of any of your household kind of big products, I mean, these are sort of integration, a lot of different ideas, right? So if you think of an automobile, of course, there's a mechanical engineering, which sort of is the heart of it. But then you have a lot more about how you can sort of electronically control all of these different kind of components of your car. You have a brain in the car, like a little computer that's controlling all of these different sort of some pieces of the car. So and also, I mean, you have to think about ergonomics, right? I mean, when you're sitting in that environment, what works with you, right? Psychology, how you are interacting with this environment. So a lot of different things are sort of being integrated into a product, right? And that requires you from things like the technology, of course, the engineering and the computer science and the electronics. But there are also things like psychology, the things about anthropomorphic, right? I mean, how are you able to sort of sit comfortably in the car? Or maybe the finance, right? I mean, even if you have an idea, but that idea is not good enough to be sort of brought into the community unless it is sort of profitable and things like that. So any product that you see is an integration of all of these different ideas. So there are big teams that are sort of sitting behind and sort of going through this interdisciplinary kind of aspects of it and see how to make this product successful. So coming back here to an automobile design, it is it's a lot of integration of many ideas, and that's true for almost anything that is successful. It has to be kind of really interdisciplinary in nature.
So the next question is, so if I want to pursue solar engineering as a full-time career, so what are the scope of placement?
I think solar energy is going to become more and more important in our daily life, right? Whether, I mean, we don't want to be dependent on fossil fuel, right? So the gas and so forth that you see is, I mean, people want to be less reliant. That's one thing. Also, you want to think about environmental friendliness, right? And there again, solar energy has a big plus. So there are many different aspects that would kind of drive the solar energy in the future. Now, regarding where you can work, I don't have a good idea of the companies in India, but of course, I think that's I would expect that to be growing over the entire world and including India.
The next question is, sir, I want to become a web designer. What skills should I learn? Is computer science degree necessary?
I would say that computer science would definitely be a good step, right? It's not necessary, but on the other hand, having the degree in computer science would definitely be helpful.
So there's another question which is related to law. Sir, I want to do law as I love to debate. So which course exactly I have to do for it, and from which country or state?
Well, I mean, law again is a great career, right? If you think about, we were talking about automobiles, right? Of course, I mean, there's a design aspect of it, but then also the lawyer is sort of a sort of backbone of how to make the product sort of successful in the community. So I would say that law is, of course, it's a great profession, and I know that recently many important sort of law schools have come out in India, right, and very highly competitive and things like that. And of course, you can look into what are all the different avenues for you to kind of pursue a degree. When we were students, I think the law were typically part of most universities, and but I'm not 100% sure what are the special law schools in India at the moment.
So there's another question, which is, which one is better, React Native or Flutter for mobile? And he's again asking about, is computer science degree necessary? I think it is a lot where computer science degree is important or necessary.
Well, I mean, computer science is a good degree, and whether it's necessary or not, I'm unable to say.
So which one is better, sir? React Native or Flutter for mobile development?
So I don't know whether you got the answer here, but I think computer science is a good program. It's not necessary because you could be doing other things, and you could be using computer as a tool for that work.
You know, Advita, I'll just come in, Dr. Sunil. Mohammed, yeah, just hold on. Actually, you know, his question was related to mobile. The question is, which one is better, sir? React Native or Flutter for mobile development? And is computer science necessary? So I don't know. So Dr. Sunil is not an expert in mobile, but please.
Yeah, I'm not very clear about the question itself. What does it mean by Flutter for mobile?
There are two famous technologies for building cross-platform mobile apps. So I was just asking for which one is better. They're rivals.
Yeah, unfortunately, I don't know enough about the mobile apps and so forth. So maybe I'll sort of let that answer be sort of or question be answered locally by your teachers.
So there's another question, which is, sir, in this pandemic, in which way we can take help from robot in tracking COVID-19? COVID-19.
Yeah, it's a great question. So as you see in COVID, what you want to do is avoid a lot of contact with people, right? So especially if you have somebody who has been identified positively in COVID, you want to be able to sort of maintain that distance and so forth, but you still want to help them. So robots are a great tool for that because the robots will not get COVID, right? And they can go closer to the individual and help them out. So a lot of patient interaction or patient support can be done through COVID. And there is a lot of that. So if you look at you can search on the web, you'll find actually a lot of some of that's going on.
So the next question is, so which has been more valuable in our career, your education or your experience?
I think both of these go hand in hand. I mean, when you study for a degree, that sort of gives you confidence, right? But your experience is what you do, you add on to that over time, right? So both of these are important, and I think it's the hard work that is important to take your idea and be successful in your life.
Yeah, Advita, I think let this be the last question, I suppose. Yeah.
So yes, sir. Yeah. Sir, if I choose automobile engineering, which thing is more important to remember? Which thing is most important to remember?
I don't kind of fully understand the question. I mean, if you are doing automobile engineering, then of course the technology. I mean, you have to sort of know the basic physics or mechanics of how the automobile works. But of course, I mean, you're using many other things to make it a successful kind of career for you.
So I think he wants to ask that if he's choosing automobile engineering, what pointers he should keep in mind to opt that course. Like what course or what are the most basic thing that he should know before opting for it?
Well, I mean, physics is very important, right? Physics, chemistry, those are all kind of the heart of automobile design. So those are quite important to know and understand it. But of course, I mean, that's not all. You have to think about many other ideas that sort of get integrated into an automobile.
Okay, so without further ado, I would like to call upon our principal, Colonel Prem Prakash sir, to say a few words about the session.
Yeah, thank you, Advita. Let us, I think, thank Dr. Sunil Agrawal for lovely, talk and interactive session. I think he wouldn't have expected so many questions from the students and otherwise. Yeah, so in fact, it is a pointer for us for the career counseling team that the students are what type of the questions they have in their mind, and so we could address some of these. And so I think in a way that when there is expert talking on a subject, so a lot of these questions do get generated. So that is really great. Yes. So coming back to Dr. Sunil Agrawal, so very much thankful for to him who have accepted our request and talking or interacting with students of 9th to 12th. And we've been having this career Mela for a while now, for 5 years, and so of course here during offline time it is much easier to get experts, of course, locally. But this online thing, it's been the luxury of having people from abroad and experts as far away New York or Australia or the other places we've had. So I think that in a way is again good use of technology that we've been having. And so I'm really very grateful for that. And I'm sure all the students would have got not only glimpse, a great insight into what the interdisciplinary fields are able to do. And in fact, recently we've had two students joining IIT and two NIT, and in fact one of them I think was keen to take engineering as also medical kind of thing. So for such students and also the other students who are now in 11th at least, they get an understanding of this multidisciplinary approach and how things can help. The other thing I would just wanted to share. In fact, we have Dr. Sunil, we have this ATL lab, ATL lab, with the Niti Aayog had started a few years ago. So we are one of the first schools who have got grants for that, and we started this ATL lab. And this has got all the this engineering kind computers, and including 3D printing, and so on. And so we have some students there, and we are making a lot of these prototypes, including of Robo. And Robo, of course, here the DPS organizers of this inter-school competitions where our students have participated and done very well. And so that one, then drone, and in fact one of the students who asked you one of the questions here, Sarthak, and so he made one Robo to try and clean up the sewage. There is a lot of this issue is very burning here in India because of the manual versus the using machines for that. So he made one, and I think he got some award also, this ATL. So in fact, Mr. Pandey, NK Pandey would be here, is part of the in fact looking after ATL. So I was wondering whether of course we cannot do what you are doing, but can the ATL type in high school start or learn or try and understand something of what you are doing in the lab there?
Yeah, so Prem, that's a great question. So even here in the US, we have a lot of high school programs that we all work with, and the goal is to sort of get students interested into technology or science or mathematics or engineering early on as they are in completing their high school degree. Now, I also have some of my friends and colleagues who I know at IIT in Patna, and maybe there would be a good contact for you. Maybe I'll sort of get that information to you later on, because they are working in robotics, and in fact, they were working on programs like Swachh Bharat and so forth. So kind of look at the how do you kind of dispose of trash and things like that using robotic technology. So maybe that will be a good connection for your school, because IIT Patna is locally for you, and I mean they could be good mentors for your students.
Yeah, first class. Yeah, we've been in touch, I think, here with the IIT Patna. In fact, some of our students, and in fact, they had a program for the girls, especially. So last year they had gone there, and with IIT and NIT. So that will be great. And then, yeah. In fact, just to add on to what Dr. Agrawal had mentioned, Sunil, regarding the motivation, in school. So, we had great teachers. And I remembered, in fact, when Mr. David, his birthday was yesterday, so there were these messages there. Of course, he was teaching English. So many of these variants and other people who are in Patna, so send these messages. Then we had Father Scaria, who was the principal, as also, is to teach physics. And in fact, last year around December, I went and met him here in St. Michael's. He stays. So and such a very forward-looking kind. So for our students, so these teachers, as mentioned, by Dr. Sunil. So I think all of the students must look forward to, such role models. And Mr. K. N. Pandey and others who used to teach maths and all. So they were again great people. Right. So I would actually just like to thank in the end and for a very interesting session. And for our career counseling team and Mr. N.K. Pandey, so you have some of these things which we can take it forward and follow up, on those aspects. So again, I am sure you must be getting ready for your probably classes there. It must be what time now? I think 9:30 or 10 or something.
Yeah, 9 o'clock in the morning, 9:10.
9:10. And so pending US elections, wonder how is New York and what is happening there. And so I'm sure there's a lot of confusion. Right. So anyway, so thank you very much, Sunil. And we'd also like to thank all the Vice Principal, the Career Counseling team, Manoj, Advita, and all the teachers and students, and probably some of the parents who would have also joined. Okay, that's it, I think. Manisha, anything else? You did not ask question. You said you had some question to ask.
Sir, the enthusiasm of the students was so much that I let it go that way. Maybe personally could send messages to sir.
Okay, Mr. Pandey, N.K. Pandey, anything you have? It's a good opportunity. You don't have professor from Columbia University easily available to chat up with.
Yes, sir. Yes, sir.
Yes.
Actually, I wanted that sir will take a session on mechatronics, sir.
Okay, on megatronics.
Yes, sir. I request sir that one session sir will organize on mechatronics also.
Yeah.
We all will be very grateful to sir if he organize such type of seminar on that topic.
Yeah, mechatronics is, of course, it's a nice name. It's mechanics and electronics.
Electronics.
Right? So that's how the word comes as a mechatronics. So a lot of robotics is all about mechatronics. It's machines and electronics together. So often we in our programs, we have classes in mechatronics that would actually kind of give students that experience of being able to design and interface things with a computer.
Okay, right, I think so. And Mr. Pandey, regarding ATL and our students, we must follow up on what Dr. Sunil suggested, and then let us. Although you see, because of this COVID, students are not coming to school, so we are not able to really do much work. But all the same, whatever little bit they are doing from home, kind of thing. But now, since some students have started coming, in fact, starting today. So we'll probably have this activate ATL a little more and then try and move ahead. That's all. Anything else? Any other teacher has? Or last, we will close with that, I suppose. Nothing? Okay then, Dr. Sunil, I think, thank you very much for being here.
Well, okay. Thank you all for inviting me. It's a pleasure. And of course, it's always nice to talk to young people. And I know that many of us have questions as we are growing up, and happy to be of some help today.